Some strain values are measured on the free surface of a mild steel. In this question, our goal is to determine the principal normal strains and the principal shear strains. We will assume that no yielding has occurred. At first, I will write the material properties for mild steel. From table 5.2, we can obtain Young's modulus as 212 GPa and Poisson's ratio as 0.293. Let's start by finding the center of the circle. Let's call it A. It will be equal to epsilon x plus epsilon y over 2. And it is and we get A is equal to minus 285 times 10 to the power of minus 6. Let's say that this point is minus 760, 150, and this point is 100, minus 150. I wrote 150 because, as you can notice, this axis is gamma over 2. It is not gamma. So, I know that this length is radius, so let's calculate the radius too. Radius will be equal to epsilon x minus epsilon y over 2 square plus this time gamma xy over 2 square. And we will get 498.12 times 10 to the power of minus 6. Since we know A and R, we can now calculate epsilon 1 and epsilon 2. Epsilon 1 will be equal to A plus R, and it is minus 285 times 10 to the power of minus 6 plus 498.12 times 10 to the power of minus 6, which is 213.12 times 10 to the power of minus 6. And epsilon 2 will be A minus R, which will give minus 783.12 times 10 to the power of minus 6. We know that from generalized Hooke's law, epsilon 3 will be equal to 1 over E times sigma 3 minus Poisson's ratio times sigma 1 plus sigma 2. But since there is no yielding, sigma 3 will be 0. But to calculate epsilon 3, we should first calculate sigma 1 and sigma 2. How can we calculate them? Again, by using generalized Hooke's law. We know that epsilon 1 is equal to 1 over E times sigma 1 minus Poisson's ratio times sigma 2, and sigma 2 is equal to 1 over E times sigma 2 minus Poisson's ratio sigma 1. I will first add epsilon 1 and epsilon 2 together. Let's do the calculations here. This will be minus 570 times 10 to the power of minus 6, and it will be equal to 1 over e times sigma 1 plus sigma 2 times 1 minus Poisson's ratio. And now I will subtract epsilon 2 from epsilon 1. And it will be equal to 996.24 times 10 to the power of minus 6. And it will be equal to 1 over e times sigma 1 minus sigma 2 times 1 plus Poisson's ratio. When we make some arrangements, we see that sigma 1 plus sigma 2 is equal to and sigma 1 minus sigma 2 is equal to these equations will give us sigma 1 is equal to minus 3.79 MPa and sigma 2 is equal to minus 167.13 MPa. Now we can calculate epsilon 3. Epsilon 3 will be 1 over 212 GPa minus 0.293 and this is MPa, and it will give epsilon 3 is equal to 236.22 times 10 to the power of minus 6. Let's continue with the shear strains. Gamma 1 will be equal to epsilon 2 minus epsilon 3. And we know that it is 1019.34 times 10 to the power of minus 6. Gamma 2 will be epsilon 1 minus epsilon 3, and it is minus 23.1 times 10 to the power of minus 6. And finally, gamma 3 will be epsilon 1 minus epsilon 2, and it is 996.24 times 10 to the power of minus 6.